Hello, and welcome to this hopefully quick walkthrough of my final project for LLM-Zoomcamp 2024. So here I am in the GitHub repo, playlist guide LLM, and if we scroll down here, we see just a little bit of overview, steps to reproduce, walkthrough video I'm working on, well, right now. You could, if you have a GCP account, you would just look for YouTube, go to YouTube API v3, manage, create credentials, and then get an API key. So part of what this project is going to do is be pulling transcript data from YouTube. And then just how to add that to your .env file. You will also need OpenAI API key to run the app itself. If you do not have one, hopefully you don't ding me too much, but I tried with Ollama, wasn't really doing too well. And then here's how you would set up an env file. And you'll see in just a moment I have that in my project. So jumping right in, you just git clone, use the HTTPS because obviously you don't have an SSH key. So I have that here locally, and I'll make this a little bigger and git pull. So up to date. So this should be exactly what's in GitHub right now, and you just need to cd to app. Let's see, where did I mess up there? Oh, no slash. And then you could do docker compose up -- build. I do have a make file here. That was just more for development, restarting individual containers. But you could use that here as well and just do a make up. And if you're running this for the first time, especially the app container, I think that can take maybe 20 to 40 minutes. So I would actually kick that off and just walk away, do something else, check back on it in a bit. Yeah, so just be aware that's going to take a little while, and also when you start the app, that's probably going to take a bit of time as well for Elasticsearch to load. So now that that's coming up, let me switch back here and localhost 8501, and we can just refresh that. And let's see, where did, actually let me see if I can make that bigger, discuss monitoring, and then search. Okay, sometimes that might come back with a video title NA. That means Elasticsearch is still loading its data. But you get here a summary of the video. We discuss monitoring in LLM systems, focusing on the importance of evaluating the quality of answers. And this should take us to a reasonable point in the videos where that is discussed. Okay, I'm going to go ahead and close that, and then we can look at the feedback. For that, I'm actually going to move this out of the way for a moment and just open up, or actually I guess I didn't need to move that out of the way, admin, and admin. And if you're not sure what these credentials are, those are what you defined in the env file, which would be here. In my case, my local version has admin instead of admin password, and admin at admin. Okay, so let's log in here. That's fine. And let's see. Let's remove that, and I'll show the setup from scratch. We would just register server. This really doesn't matter, whatever name. The connection does need to be DB because that's how it's defined in the Docker Compose file. And username is db user from the env file, and the password is admin, again from the env file. Okay, so if we expand this out, we do have a database called transcripts, and in transcripts, if we go down and expand out, we have bad responses and feedback. So I'm just going to go ahead and open up the query tool and select star from feedback. And there's probably going to be some data in here. Okay, I'm just going to go ahead and truncate that. Just empty it out. Control Z to get my select back. And we see that is empty. Now if we go back to the app, yes, thank you, this was helpful. And we're going to get a message here that it's been inserted into the database. Unfortunately, you do need to reload to ask another question. But if we go back here, now we see we have the ID, which is just a unique identifier of the feedback, the question that was asked, the answer which was passed back. We see the feedback, thumbs up was positive, the title of the video, the link, and that can have a timestamp with it, and then this is the date and time of the feedback. Okay, so that's pretty much the entire system, getting it going. Again, a little bit of time, but now I'll circle back and just kind of walk through a few things. The repo is a little messy, unfortunately. This project is technically due in 45 minutes, so hopefully I can get this posted and get a good GitHub hash to get that submitted. Okay, so when you come in here, let's see. You have app evaluation. Images is just for the GitHub repo, the README. You'll see those there. Research, I threw a bunch of files in here. These are not needed. You can just wave your hand at that. I just want to keep building on this later and didn't want to lose any of my work. I'm not the most organized. So transcript pulls. When I started out, I was trying to pull the full transcript and then the title of the YouTube video. And if we look here, scrolling down, actually let me zoom out so I can actually navigate okay. That's the playlist ID for the LLM-Zoomcamp playlist. So this just goes through and pulls, well, all the transcripts and then the title. Using Elasticsearch, I didn't really get too good of results with that. So then I had the idea to pull the, well, I had YouTube determine the timestamps, and then it creates a whole bunch of little chunks. So I had the title, the timestamp, and then the text in that section. That didn't work too well, so then I tried chunking them with the chunk immediately before it and immediately after it. That didn't work so well. So you can see here, I tried doing it, well, doing it that way was the segments. So I was trying to make the chunk size 3, saying, hey, start at the beginning, take the first 3, and then the next one's going to be the one before it and the one after, so on until the end. Again, didn't work too well. Then I was trying to do it with the time gaps where, hey, look at this rolling window of time. If I can find that here. So that must have been a about 30-second window. I should have probably reviewed this. Let's see. Okay, yes, time gap 30 seconds. So if they fall within 30 seconds, okay. So again, that didn't work too well. So this tripped me up for a long time, and finally, what I ended up doing was, let's see, let me just, what videos pertain to Elasticsearch, that should work. I just want to pull one up so you can see. So what I ended up doing was actually grabbing each video, the title, and then the description, and then had it look at the time codes and said, hey, look at these time codes, give me this text to be in that row. So we have the title, the description, the name of the time code, and then give me everything from that time code until the next. Give me that transcript text. And then do that to the end. Unfortunately, the Mage videos didn't have time codes, but I said, okay, well, just give me the whole video. And actually, we could probably do that here. Did we cover Mage? And actually, let me pull this one up real quick again. Well, here, I'm going to roll with this a little bit. Orchestration Module 5. And you see here, yeah, we still don't have the time codes. Okay, let's say, okay, had a little hiccup there. So, how do I use Grafana? And let me see if it'll yell at me for searching twice. Oh, now it's giving me something else. But you see, here, it dropped me into Grafana, add a timestamp. And why did it do that? If we look here, well, it's got Grafana there, and yeah, that's probably what it was looking at. Have I left any other feedback? Let's see. So I could leave feedback here. Or actually, I think there's a separate Grafana video. No, there would be a better video. Let's see what some negative feedback does. Just refresh that. And there we go. Okay. So, what am I using in Elasticsearch? Well, let's go back to the code. If you look here, well, first of all, we should probably say, how am I pulling this data? So under app, there is data here, and what that's going to do, you can ignore that fixed ground truth data. This is going to be that same function that goes out, grabs the video title, the description, the time codes, and the text in between. But then what it's also going to do is once it reads the video IDs, it is going to output them to this processed text file. Okay, and then on subsequent runs, it's going to, I don't think I changed anything. Oh, I closed the wrong thing. Let me open app back up. So if we scroll up here, oh, we wanted the pull data. Okay. So if that file is present, read it in, and then as it's looking at the video IDs, just say, hey, just process video IDs that we have not seen before. And if you go down to the bottom, I guess I could have started there. It's going to read that in, and then just add the new records and write it back out. I was kind of considering putting this in the Docker Compose file with the other services, but to me it kind of makes sense to have it outside in case somebody adds time codes later or updates the description. I could just easily delete that, run it again, and this data directory is mounted to, I believe, that's Grafana, which I do not use. The data inserter, which of course that's going to insert the data, and then it should also be I guess just the data inserter. So that's going to read the records and put them into Elasticsearch. And if we go here, we can kind of see what that's doing. So it's making some encodings and, well, loading those up for a hybrid search. And I think that pretty much covers what the app is doing. So real quick, evaluation, that really helped decide what kind of Elasticsearch to use. It's probably not optimal, but it's better than when I started out. I was just using one vector search, and I do get that from time to time. I do need to hit restart, and I think that usually fixes it. Or maybe that's normal. Okay, then we load up the model, and then we append the records. This is the first type of search I tried to do where it's taking the title, the text, and the description. I probably maybe should have tried with the timecode text as well. That's going to take a moment to spin up. And while that's spinning up, if we go over here to transcript pulls, you can kind of 5 and 6 here are how I generated the ground truth. It was asking OpenAI to make 3 potential questions for every entry. I do have, well, there's a hash function that creates the ID. I believe that is in the data pull itself, but you'll see they're in there. So once I made that, cleaning the ground truth, I was going to put it through Ollama to try to extract the right data, because it came back a little mangled, and it made a list of student questions in every row rather than making 3 individual rows. So going through here real quick, you can kind of see the original transcripts. This ID is the hash. The video ID is from YouTube. Trying to return those questions. Not sure if that was Ollama or... Oh, this was another go at OpenAI. And this was cleaning that data that came back to try to make 3 rows out of each one based on the number of student questions. Don't think I have this set up to run. If you look here it still shows them. This got it to the point where it was cleaned. They were in dictionaries, but again, 3 student questions for every row. And down here, that's not where I split it, because, yep, there we go. Treat it as a literal list, and then this is the function which actually split that up. And if you look here, I had 279 records originally, multiply by 3 student questions, and that was indeed the 837. Ground truth became fixed ground truth because some of the IDs were missing, but the fields that I use to do the hash are actually there from the YouTube data itself, so I just regenerated those. Okay, so Elasticsearch looks like that encoding is done, and you see this is just one vector, the text vector. We can run that, insert the records, and all right. And when did we talk about Mage? Can do that question. Run that to define the search we're going to call, and then here we're going to go through this fixed ground truth for every student question. We're going to see if that's in the returned results. And okay, now that we have the relevant totals loaded up, we can do the hit rate, which is 0.454, and the MRR, which is 0.65. So here, what I did, and again, there's, I don't know, probably at least 100 different combos, ways you could combine these, but I went ahead and made a vector out of the title, the timecode text, the text that's the transcript, and the description from the video. That will probably take a few seconds longer to run, hopefully not too much. While that's running, you can see it's the same as before, but there are now 4 vectors. And then if we keep scrolling down, let's see, we have a keyword query with the description, text, and title, and then this is going to be our hybrid search, where it uses both the vector and the keyword search, and searches that way. Okay, I was hoping by the time I was done talking that would be done. But maybe I might need to pause it. And of course I stopped the video and this code quit running, or finished running. Okay, so I'll run that. We'll load those up. Okay. And then for each one of the vectors, I just said, hey, for each one of these, go ahead, do the search for each student question, and then, print out for each one of these what the hit rate is going to be. Oh, it looks like it jumped down at me, or jumped down on me a little bit. This won't be too bad, so you can jump ahead until, let's see, 1, 2, 3. There will be 4 bars when this is done, and then we can kind of look at that. Okay, so that's finished. The winner here is hybrid, or the timecode vector for hybrid search, and then we're just going to kick this off then to get the MRR. Again, this last one took a minute and 20 seconds. Let's see how long this one takes. Okay. Again, this one took about a minute and 20 seconds as well. And the timecode vector is the winner again. Text vector is close second here. Yeah, text vector. And if we go back to app.py, I don't know, just maybe I should have, well, I ran out of time to really test it with text vector, but just as kind of a gut feeling, if you go in here, you can see that That's not what I was looking for. Ah, yes, the text factor is what I used. Maybe could have made a drop down and selected between those. Be good to compare the feedback. And yeah, again, a little bit of a time crunch. And if you look through this code, pretty simple. Makes the tables, initializes the database, and here is where you're going to need that OpenAI API key. And then you can see the prompt that's being used. Please return answer as a dictionary without JSON ... And that worked pretty well. If you look down here, it did not always work. I think it's working pretty smoothly now. But when you submit the feedback, that hung me up saving the state. That's why you do need to refresh the UI. And then just the insert into the feedback, and then, hey, if it comes back and it's not a dictionary or something that can be inserted, just go ahead and dump that into bad responses so those could be looked at. All right. So I am not going to go into what I would like to improve, because this will be evaluated on just what I have done. And I did try to be pretty explicit and straightforward here in the README. But you never know. Sometimes questions come up. So hopefully this walkthrough, and I could have cleaned up the GitHub repo a little bit better. So hopefully this eliminates some confusion, and that way you can just kind of git clone, make up, and then go from there. All right. Hopefully this was helpful.